Let's do problem 2 from your lab assignment from section 2.3. Here it's asking us to look for the limit if it exists. And this limit expression is an expression that says limit where as x approaches negative 8 of a fraction 9x plus 72 divided by the absolute value of x plus 8. Now this absolute value as x gets closer to 8 would make some weird things happen. So let's see what's going on. In step 1, they're asking us to recall the definition of the absolute value. And the absolute value says that, well, we know that the absolute value takes whatever's inside of the absolute value and makes it positive. Well, that's to say that if this thing is inside the absolute value is already positive, and it's already positive if x is bigger than negative 8, then it'll remain the same because it's already positive. Now if we put in a number like a really small number like negative 9 in here, this would make into a negative 1, and absolute value of negative 1 is positive 1. So we're essentially wanting the opposite. That's to say that if x plus 8 is a negative value, then we want the opposite of that. So we want the opposite of x plus 8. So this is the definition of the absolute value, and this definition is just extended because we had a plus 8 added to it, but in general that's what we're looking at. It's the thing inside of the absolute value. So what we want to do is check the limits approaching from the left and from the right to see what happens. If we start checking the limit as it approaches the left hand side, so we're going to approach x from the left hand side, then we're looking at numbers that are less than negative 8. So coming from the left hand side, we're looking at numbers that are less than negative 8. If we're looking at numbers that are less than negative 8, then this, by definition, numbers that are less than negative 8 will have to use this part of the function. So our limit will actually take a look at 9x plus 72 divided by the negative of x plus 8. So that's what we need. So now that we have that, we're going to use this expression as x approaches 8 from the negative side. And so what happens here, it looks like in this step they want us to factor and cancel. So we take the numerator, 9x plus 72. If you notice that 9 and 72 have a factor of 9, and if we factor that out, we're going to get x, and then 72 divided by 9 is 8. So we have that. So that's the factoring part. And now that we have common factors, we see an x plus 8 and x plus 8 that we can cancel out. And so we're going to get 9 in the numerator and negative 1 in the denominator. So that's equivalent to having a negative 9 simplified. So we're taking the limit as x approaches negative 8 from the left side, and then a value simplifies, or expression simplifies, to negative 9. And so there's no more x's involved, and so the limit's just going to have to be negative 9. So we have the limit as this approaches negative 8 from the left hand side. Now let's see what happens on the right hand side. So we want x to approach negative 8 from the right, so that means we must be looking at values that are bigger than negative 8. And if you look at values that are bigger than negative 8, we're going to consider this function x plus 8. So we have a 9x plus 72 divided by, and so here we'll just have an x plus 8. You can put parentheses or no parentheses, either should work. And now we're going to do the same thing. We're going to factor the numerator. It looks like there's a factor of 9, and then now we have x plus 8 here and then x plus 8 in the denominator. We can cancel that out and get 9, and this time it's not just it's 9, it's a positive 9, and that's different from the negative 9 that we found. And so since the left hand side and the right hand side limits are different, the limit here does not exist. So it says we have to enter DNE, so let's go ahead and enter that, and then that's correct. Now let's verify with a graph, and I'm going to pull out Desmos again, and let's take a look at that function. Y is equal to 9 x plus 72, and then we have to divide. So let me see if I can highlight this whole thing and hit the divide button, and then we have the absolute value of x plus 8. Close the absolute value. Now as you can see, there's something kind of weird going on here. The graph is in red or burgundy, and it looks like the graph kind of goes up and goes up, so there's something weird happening. If we trace along here, as x approaches 8 from the negative side, we're seeing that we're actually on this line down here, and then it doesn't want to go to 8. It goes to 8.01, and then I took a jump, and then now I'm in negative 7.998. So there's some weird things happening here, and this excess line that goes up here is actually an error by the graphing calculator, because these computers can only deal with finite things, and when it deals with something that breaks up like this, it doesn't know what to do with it. So sometimes it does things that might not be mathematically correct. So we want to be careful about interpreting these things. But in any case, we can see that this graph approaches negative 9, a y value of negative 9 from the left side, and this graph approaches a y value of positive 9 from the right side, and that would show that the limit does not exist. Okay, I hope that makes sense, and good luck.